The average distribution grid in the US operates at about 42% utilization rate, right? In that you've already today upsized our distribution system based on a projected theoretical load that is far in excess of what our actual consumption is on a normal day, on a given day. That problem gets a bit more acute when you think about reverse power flow coming from solar export, etc. But layer on top of that, homes that we are in today, tens of thousands of homes across the US and all 50 states. If you look across all 200 amp homes that are fully electric, 98% of those homes have 80 amps of unused capacity 100% of the time.
Hardware to Save a Planet explores the technical innovations that are giving us hope in the fight against climate change. Each episode focuses on a specific climate challenge and explores an emerging physical technology solution with the person bringing it into reality. I'm your host, Dylan Garrett. Hardware to Save a Planet is brought to you by Synapse. Make sure to click subscribe so you don't miss any future episodes. Thanks for listening. Hello and welcome to Hardware to Save a Planet. I'm here with Arch Rao, the founder and CEO of Span. Arch founded Span 7.5 years ago with the goal of reinventing the home electrical panel. Span's panel is connected and smart, so it empowers homeowners to monitor, control, and optimize energy use down to the circuit level. It also plays a big role in enabling the adoption of solar, batteries, electric vehicles, and electric appliances in the home. Span launched their first product 5 years ago, so I'm really interested to hear how the story of Span and Arch evolved over the years and what it's been like to scale the company since then. Arch has spent much of his career at the forefront of home energy technology. Even prior to Span, he was leading product for Tesla Energy. Arch, it's really a pleasure to have you on the show. Thanks for joining us.
Yeah, thanks for having me on, Dylan. Very nice to meet you.
So we were just chatting a bit before I hit record about kind of our shared interests and shared backgrounds. I was looking through your LinkedIn and I see we both studied mechanical engineering in university around the same time. And based on what I see on LinkedIn, it looks like you were interested in sustainability early on as well. So we kind of come from similar places in that sense. I've talked before on the show how I ended up taking this other path where I was like not finding a job in sustainability that it was exciting to me, and kind of went down this product development path for a while. It seems like you stayed the course, you kind of stayed in the energy and sustainability space. I'm really curious, what were you seeing at that time? And this is way back then, that was interesting you and kept you kind of down that path that, what was I missing?
Yeah, I think you're right. We had sort of similar inflection points around the similar time periods in our careers. I did my university degree in automotive engineering because I really thought that the transportation sector was where I wanted to go ahead and have some meaningful impact. And I wanted to build what at the time seemed like the complex machines that were out there. We're increasingly building more advanced engines with advanced control systems. There was more robotics going into automotive manufacturing. This is late 90s, early 2000s. And then that kind of spawned my interest in energy and energy conversion. So by the time I got to grad school, my focus was much more on the energy conversion technologies, more so than the machines that were powered by these energy systems. So a lot of my academic work and PhD work was focused on, ironically, engines and combustion engines and how to make them more efficient. I've shared the story a couple of times before, but embarrassingly, it took me a good 3 to 4 years to realize that Carnot efficiency limit is real, and I wasn't going to get a combustion engine to be more efficient than the physical theoretical limit, if you will. So the solution had to be sustainable solutions. The solution had to involve electric vehicles, had to involve new chemistries for batteries, had to involve higher efficiency power conversion technologies. And like you, I think I went to see what options are out there for a job and found many of them to be somewhat lackluster. I did not want to be an energy efficiency engineer, updating HVAC systems in a building. So I said, well, we should just build the products we need to have in the future. And that's the path I've been on for the last 20, 25 years. It's starting with wind energy technologies to energy monitoring technologies to batteries to now smart electrical panels.
Yeah, that's where I went wrong. I mean, exactly the same thing. I don't want to go work on HVAC systems, but then I didn't quite have the guts to go build my own products.
I think it's depth and breadth, right? I focused on picking what I believed and sometimes naively believed and had conviction around a problem that needed to be solved with a piece of hardware. And I think you went the breadth out to say, how many different types of products can I help enable build that could solve the macro problem of sustainability, right? So I don't think it's that far apart. Yeah.
So Tesla, I imagine I didn't go deep into what exactly you did at Tesla, but you were in the energy group, so working on Powerwall, solar, like rooftop solar as well.
My time at Tesla started when I got better acquainted with JB Straubel, who is one of the co-founders of Tesla and at the time the CTO at Tesla. He was really passionate and had strong conviction around the need for grid-tied batteries and leveraging obviously a lot of the science and engineering that Tesla had done around batteries and inverters and control systems, right? When I joined Tesla back in 2012, 2013, the car company itself was still sort of in its emergent state. And there was a small R&D group that I got to be part of that was focused on energy. And we were borrowing modules from the Roadster program or the sort of very early Model S program to try to create what we called stationary energy storage at the time. The business group wasn't called Tesla Energy. It was this small R&D team called stationary energy storage as opposed to obviously mobile energy storage in a car. We got a kickstart from, quite frankly, the California Self-Generation Incentive Program, SGIP, if you recall. So the first few battery systems we built were what we call the Super Pack, and they were skid-mounted batteries that were installed in small commercial buildings, and they were used for peak demand management because the state of California and the utilities gave a very, very handsome rebate. I forget now, I think it covered nearly 60-70% of the cost of the battery. When the cost of the batteries were about $1,000+ a kilowatt hour, that was the only way you could justify deploying energy storage as a grid-tied asset at the time. That naturally sort of gave way to a partnership with SolarCity, where they were looking at home backup systems. So we built a rather unattractive version of the Powerwall. This is the predecessor to the Powerwall, if you will. There was a home battery that we deployed, maybe a few hundred of, a few thousand of, if you will, getting some real world feedback on how could we use a battery system in conjunction with a solar system in a residential setting. All of that became sort of input to what eventually became Tesla Energy. The design of the first Powerwall, which was a DC Powerwall that integrated with third-party inverters, which then gave rise to what would then became much more popular product, the Powerwall 2, where you had the power conversion inverter embedded within a single frame or a single box, if you will, and then now Powerwall 3, but also gave rise to Power Pack, which was the commercial version of the product, and then Mega Pack, which is the utility version of the product. So I was very fortunate to have a role to play in the residential, the commercial, and the utility scale programs and products that we built across hardware, firmware, and software.
And did you see the opportunity for Span while you were there at Tesla, or how did that come about?
No, it's one of those things that's hard to sort of trace back to exactly where the idea germinated. But back in, I want to say 2016, Tesla acquired SolarCity, and with that, I took on a lot of the solar products as well. So the solar inverter products, the roof mounting products, and solar roof products that we were designing and manufacturing in-house. And if you start looking at the equation through the lens of new sources and loads being added behind the meter, right? Solar systems, EV chargers, batteries, and if it doesn't take a lot of imagination to extrapolate beyond that, to add water heaters that are electric, heat pumps, etc., it became painfully apparent that the electrical panel was a device that was getting upgraded or replaced very, very frequently, right? Back in the day, we would avoid doing a main panel upgrade by essentially downsizing your solar system. Because if we went from, say, 7 kilowatts to 9 or 10 or 11 kilowatts, it became too large and we had to upgrade your electrical panel. And we would convince customers to take a smaller system and put it in place, even though the NEM 1, NEM 2 rates were very, very attractive because the capital cost of replacing your panel had to be avoided, right? But then it became less avoidable when you added a battery, because now you added another source or sink into your home, and it became almost inevitable when you added an EV charger, because you just added a 60 amp dipole load or a 10 kilowatt load.
Then you have to upgrade.
The largest load your home's ever seen, right? So not surprisingly, I was like, wait, hang on a second. All these sources and loads by design tying to this electrical panel. The electrical panel is ubiquitous. It's the natural intersection point between the power from the grid and everything in your home today and over time. But we're contending with the fact that it's an analog device. There's no reason that it's remained an analog device for the last, 50, 60, 70 years. That's kind of where I was like, what if this was a digital power control system? What if this was a router for energy? And I suppose that's kind of how Span came about.
Yeah.
Yeah.
I mean, and you don't have to go into this if you don't want to, but it feels like this could have been a really natural product for Tesla.
Could have. I think,
Okay.
We found areas where Tesla was really, really good at, right? Tesla had incredible core competency in hard things like making cells. Manufacturing cells is not something that's easy to do, let alone do that well and cost efficiently here in the US, right? The panel product is more of a systems product, and it's more of an interoperability play, right? As opposed to a vertically integrated play. Companies like Tesla and Apple are really good at vertically integrated product offerings, and I wanted to build something that was deployable no matter what car you drive, no matter what battery system you have, no matter what heat pump you get, and actually solve for a solution that was more part of infrastructure as opposed to just a closed ecosystem. Tesla's mindset on this has also, I think, changed quite a bit over the last 5 to 7 years, right? I think at the time it was a direct sale model, and Tesla was also the installer post-acquisition of SolarCity. And I think now it's they've come a long way in terms of being a solution that's much more interoperable, much more open. In fact, we are partnered with Tesla on integrations, right? The Span panel and the Tesla Powerwall go hand in glove. In fact, if I remember my numbers correctly, about 84% of storage systems co-deployed with Span are Tesla Powerwalls. So I think there's been a evolution in how Tesla thinks about products, and for me, it was always about building interoperable products because even if you think about any of our homes, you don't have appliances from just one brand or one manufacturer, right? Your induction cooktop and your refrigerator and your dishwasher, and now by extension, other new appliances, new class of appliances like your EV charger, inverter, cars are going to be an amalgamation of different brands and manufacturers and vintages. But there has to be a product that is universally applicable, right?
Yeah.
That's what Span is designed to be.
Bring it to life for me a little bit. What, as a homeowner, what is the benefit of the connectivity specifically? Relative to just upgrading my panel to 200 amp or something that can carry all these loads.
Yeah, there's an increasingly simple framework that I keep coming back to explain this, and I'll try to use that here as well. The P&E framework: power and energy, physics and economics, and that you'll find that this actually cuts across all customers, cuts across all building types, cuts across whatever channel we're in. So if you're a homeowner, let's say you're a homeowner that's looking to add a new electric load. The most common one today is an electric vehicle charger. That's usually the trigger for this. But you could also be a customer just buying a mini split or replacing or augmenting your gas-fired furnace with a electric heat pump, if you will. 2 out of 3 single-family homes in the US will require a panel upgrade and a service upgrade just based on National Electric Code rules, right? Because those homes are powered with a conductor that's rated for 100 amps, right? And in theory, when you add a new electric load, like an EV charger, is 60 amps. So suddenly you just significantly oversize the number of load or the quantum of load you're putting behind a 100 amp conductor. The solution that Span provides is power control systems. So we are able to say that even if you stay at 100 amps of total conductor capacity, our system, as you mentioned, does the monitoring and control and on-device logic, right? Or let's call it the autonomous logic, to keep your home below 100 amps no matter what. And the way we do the no matter what is to say, well, on the safety side, I can shut off a circuit if it gets to a point where it's cumulatively above 100 amps for the home. But on the customer experience side, we're able to throttle the EV charger. We're able to throttle the compressor speed on a heat pump. We're able to change the energy mode of a water heater, right? Those are the integrations we've done. So what that translates into for a customer is you get to enjoy electrification or load growth or whatever convenience you're looking for without a really expensive and long-drawn service upgrade and panel upgrade process. Right. Just to put that in numerical context, in California, and I know we both live here in the Bay Area, I think PG&E would quote somewhere between $15,000 and $25,000 on average and a 6-month wait time. to upgrade your service, while in reality, you actually don't need it. 100 amps is 24 kilowatts, is an abundance of instantaneous power you can draw and be fully electric without it. So that's the physics and power piece of it that we solve. But once you have it, we can do clever things with energy and economics. I can extend the outage protection you get by managing loads during an off-grid event. We can offer your device into a demand response or a virtual power plant program and give grid services that is a source of monetization and have you earn the economic benefit of it. But ultimately, what we're building is a product that can save you money out of the gate, has day zero economic value, and then hopefully continues to provide functional and economic value over time.
Got it. And then from a climate perspective, is the main story here about kind of easing the on-ramp to adopting EVs in the home, electric appliances, heat pumps, all of this?
Yeah, it's enabling electrification, right? And that's been our raison d'etre for forever, right? Since we started the company. And maybe peeling a layer further back, I think the conversion of our lifestyle from gas to electric is the most significant way for us to positively have an impact on climate change, more so than even clean power generation. That's important as well, but let me maybe share a hyperbolic point of view, right? Even if I were able to magically put solar at no cost on every single roof across the United States, if my appliances are powered by gas, it hasn't helped me, right?
Right.
No magic way to supplant those gas molecules with free electrons, presuming they're free, right? So the thing that we need to solve for is what is the least friction path to migrating from gas to electric, right? How do I get your cooktop to be electric? How do I get your car to be electric? And 80% of charging happens at home. How do I get your water heater to be electric and space heating to be electric, right? And that electrification is the unlock for positive impact on climate, but is the thing that is significantly gated with the analog infrastructure we have around the world right now, right? And this is true universally, not just here in the US, right? Most electric grids are trunk and branch model grids. And the way we design them today is to say, what is your theoretical maximum load? And I'm going to upsize my service line. And then I'm going to upsize my pole mounted transformer. Then I'm going to upsize the distribution cables. And I'm going to upsize the substation. That is the significant amount of capex that we should not be investing in, or can avoid or defer, if you will, and instead apply towards the gas to electric transition. That's our mission.
If I understand right, by being smart about when we apply these loads and making sure we stay under whatever the capacity of the existing grid is, by controlling what's happening behind the meter at the edge, at each home, we can avoid all this expensive infrastructure upgrade because we don't need all of these appliances to be on at the same time.
And in a way that doesn't actually impact your practical convenience, right? Because I'll give you a couple of numbers that I've shared in the past to sort of illustrate that, right? The average distribution grid in the US operates at about 42% utilization rate, right? In that you've already today upsized our distribution system based on a projected theoretical load that is far in excess of what our actual consumption is on a normal day, on a given day, right? That problem gets a bit more acute when you think about reverse power flow coming from solar export, et cetera. But regardless, the average utilization is about 42%, right? Layer on top of that, homes that we are in today, tens of thousands of homes across the US in all 50 states, and we've looked at this data empirically. An average, if you look across all 200 amp homes that are fully electric, 98% of those homes have 80 amps of unused capacity 100% of the time.
Wow.
Right? 98% of 200 amp homes have 80 amps of unused capacity 100% of the time. That means services are oversized because they're based on an analog math that we're doing. But if you look at it through the lens of the physics, it does make sense because you can't undersize an analog system, because what if I do draw 200 amps or worse yet, 225 amps or 250 amps at some point in time? I need to be
ready for the kind of maximum case.
That's right. And same goes for 100 amp homes, 40 amps of unused capacity in 86% of the homes 100% of the time, right? So the opportunity is there. And what we've done is really parse through the data to see what frequency and duration of load management do we have to do in order to avoid a service upgrade. And it ends up being 1% of the time, right? Less than 10 hours an entire year 8,760 hours in a year, do I have to do the controls? And the average duration of a control event is about 6 minutes, right? So when your EV is on at the same time, your water heater is on at the same time, your electric dryer comes on, I'm going to derate your EV charger by 30% for 15 minutes or 6 minutes in a way that you didn't even perceive the impact of. And we're fully electrified. And that's the meat of what we've solved, right?
So what does all this talk about, like modernizing the grid, and we need more capacity on the grid? I mean, if I kind of simplify what you're saying, it sounds like no, don't worry about the grid. Just like change what we're doing at the edge of the grid.
Yeah, look, to be fair, there are parts of the grid that are really aging and need to be upgraded for safety reasons, right? There are parts of the grid that need to be undergrounded for weather-caused event reasons, right? But a good majority, and our friends at PG&E will tell you, for example, they're doing that where needed, but the total capex investment in distribution infrastructure for undergrounding, for example, I think in PG&E is around 8% of their capex investment. It's not like they're going about undergrounding everything out there. So it really becomes a question of, do we just keep reactively upgrading networks for this theoretical maximum load, or do we modernize with better digital infrastructure like Span? And it's a prescient question because that's where we're at today. We've evolved from a product that you as a homeowner would buy to get better backup to a product that an electrical contractor or a home builder will use to avoid an electrical system upgrade, to now being a product that the utilities are considering as a distribution asset at the meter that they give to you, so that's the model of infrastructure.
That's what I was going to ask next. It's like, it feels like utilities should be investing in deploying this.
Yeah, they are. That's exactly the evolution over the last 7 years that we've gotten to. But we had to prove out the technology was safe, it was scalable, it was cost effective through more what I would say a consumer-led or installer-led adoption model. And we've done that now across all 50 states. And we're at that key inflection point now. And we have the first few utilities that are starting to deploy our product as a utility-owned asset, or a solution that the utility has in its in its box of solutions to utilize, instead of the traditional approach of just overbuilding infrastructure.
Right. So the utility would actually, in that model, if I'm a homeowner, the utility would install this panel in my home behind the meter.
Yeah.
But they own the asset and have some level of control over it.
There's some clever semantics. We're calling it an at-the-meter solution. So we built a version of the product that essentially uses a meter collar that we've designed. So think of it as, let's play out a hypothetical, right? You're a PG&E customer, or SoCal Edison customer, or an Excel customer, or a Duke customer. You just bought an EV, you're trying to install an EV charger. The contractor comes over and says, hey, Dylan, we can't install this EV charger because you don't have enough capacity. You don't have enough physical spaces, but more importantly, you don't meet code with the existing capacity service. So please call your utility and have them upgrade your power line, right? What would have happened historically is you call your utility and they'd say, great, we'll send an interconnection engineer out there. In about 6 months, we'll come and upgrade your service. And the estimated cost is between $15,000 and $25,000. And you're going, what the hell? I just bought a $50,000 EV, now I've got to spend another $50,000 doing this. Instead, where we're going to is the utility saying, actually, Dylan, no problem, you don't need a service upgrade. We're going to ship you, or our meter technician is going to drive out there tomorrow and install Span Edge. It's a UL 3141 listed power control systems product that can be installed at the meter in 15 minutes. And you just have to land your new loads into this free sub panel that we're giving you, right? And as long as you allow the Span device to monitor and control this load when it's necessary, you don't have to pay for a service upgrade. It's free to you. We're going to rate base the asset. Oh, and by the way, if you allow us to control it to you when the grid is really congested, we will even give you bill credit. That's the point in time we're at today with some of the utilities, right? And with some others that are saying, I can either wait for you to call me as a utility and say, hey, I need a service upgrade, or I know there are parts of the network that are already congested. What if I were to proactively deploy this into regions where we know the system is already getting congested? What if I can incentivize now a customer that typically would not even think about switching to an electric water heater, but now give them the free option, or a low-cost option, or a very speedy option at the very least, to say, when my gas water heater breaks, I don't have to worry about upgrading my panel and service. I have a device that I can just plug my new electric water heater into.
I see. They already have Span because it's been sort of proactively installed.
Like a meter rollout. That's the second proactive deployment model, right? I think both are viable. As you know, utilities in the US are fairly regulated entities. And so depending on the mechanism that is most efficient for said utility, we will see growth coming through a utility owned and deployed, increasing the utility owned and deployed model for electrification enablement.
Okay.
Yeah.
Yeah, I was going to ask you a little bit about like how do you scale a consumer product company? Because at the end of the day, you need massive, you need scale to make money as a business, but also we need to scale these kind of consumer products that drive sustainable.
You need scale to deliver impact, right? Any of these solutions. Unfortunately, you look at solar penetration across the US, we're at like less than 5% penetration of solar, rooftop solar in homes. That's meaningful. That's nothing to sneeze at, but it's also not where Australia is, for example, where they have 40% penetration of solar, right? And part of that is cost, part of that is regulation. And, we're nowhere close to even being at 5% of the homes. We'd like to get there, right? There are 78 million, 80 million single family homes. I'd love to be in 5%, 10% of those homes. And we're growing up to that. And the best channel in some ways is the utility. Right? And the utility has a good view of what the network constraints are and a good view of what solutions can be deployed rapidly.
Right. If you're counting on people hearing about Span, going to your website, ordering it for their house, I mean, you're only going to get so much scale and so much adoption.
And that's been a good early growth story for us, right? I think we like to think of the end consumer as being a lasting customer, sustaining customer. Regardless of how you got it, whether you bought it, a home builder built it in for you, or the utility gave it to you, you're now able to access a very, very powerful monitoring and control system that's tied to your home, the place where you live in, right? And that's where we see a really rich software experience being an important part of the solve as well. And increasingly, that's been a big draw for customers, right? The fact that you can now, for the very first time, without having to rely on things like disaggregation, see exactly how much you're consuming for major appliances in your home, down to dollars and cents. You're able to prioritize what loads you want turned on or off when, or better yet, you are able to identify anomalies in your home before they happen, right? Our data science team is able to identify now when your compressor is about to fail, or when your water heater pump might fail, right? Or when you have potential for arc faults or a voltage anomaly. Like those are things that are possible because we are measuring things at second and sub-second granularity with a gateway that's just a really powerful gateway.
Just based on circuit level, because you only have circuit level resolution, right?
Yeah. So every branch or every circuit in our panel is by design metered at revenue grade, and it's sensed at even higher frequencies, right? So we can do at least 10 hertz measurement, and we can go kilohertz measurement if we wanted to. And what that really allows us to do is to see things that are otherwise invisible to most folks, right? What we haven't started to do yet is to actively monetize that, but I think that's kind of the thinking here is we're building this massive amount of data. We generate about 20 to 25 billion data points a day right now with a relatively nominal fleet around the country, right? We're building this massive data model that helps us understand how does every appliance behave? How does every circuit in every home in every part of the country look like? How do we identify departures from standard operations, right? And how do we then take that and make it useful to you, make it useful to service providers like electricians, and make it useful to utilities?
Yeah, that's like massive sort of predictive maintenance at a really massive scale potentially.
That's right. And really that comes down to having, it's like a systems architecture, optimization, right? Where in the network, in this sort of this increasingly bidirectional network, do you place the gateway? Where do you place a sensor? Where do you place a controller? Where do you place the compute engine for evaluating what's happening? And to me, there's no better place on the panel, right? Or take the place of a traditional panel.
Yeah, I guess it feels like there's one potential path of scaling where utilities need this. It has a very real kind of operational impact to them, but there's also this kind of consumer pull. You're making a great experience. You're saving money and time and whatnot for your users. It sounds like you sort of leaned into both.
Yeah,
I was thinking about that.
One without the other doesn't solve, right? I think you need to have a really capable, demonstrably safe, functionally safe solution. That's what makes it a viable solution for infrastructure level assets. At the same time, I hate to say it, smart meters have had a promise that really haven't come through, because which customer do you know of that actually logs in and sees the data presented by their smart meter? Virtually
Mm.
none of us, right?
Hmm.
It's just
Hmm.
not a compelling data set, and it's not presented in a way that's useful to you. And even if you have
Yeah.
the data, you can't control it. So what's the point?
What am I going to do with that? Yeah. Yeah. Um, I was thinking about that when I was thinking about your, just even the physical device you have. And if I remember right, your first product, what you worked with Fred Bold and the team that designed the Nest and it Nest thermostat, and it feels like you really knew from early on, like you wanted a beautiful product that was kind of this, that would have some appeal, right, to people.
Look,
I'm
there are
curious.
many things that I've tried to unlearn from my time at Tesla, but one of the things I learned for sure is you want to build a beautiful product, especially,
Yeah.
think about it. Like I think about it as uh, every single day when I drive my car into the garage, I'm going to be seeing this box because it's there, right? And I'm going to see it
Yeah.
for the next 20, 30 years potentially. I would like for it to be beautiful and somewhat timeless. I would like for it to
Mm.
not be a stamped gray sheet metal thing that you want to hang a picture over, right? Ideally.
Right.
It has to
Right.
match the aesthetics of the software customer experience we're providing as well. Now, obviously, that comes at some cost, along with having partners like Bold design our product. But I think it stands out because of that. It's helped us build a unique brand. It's helped us drive awareness, at the very least, curiosity, and then subsequently a ton of education with electrical contractors. Like today, we have nearly 5,000 span authorized contractors around the country, right? And we've done that in 5 years. As you said, we launched our first product 5 years ago, and that's not an easy thing to do with an unsexy product that people don't wake up and think about, right? Um, and I think we've done that because I think we've built something that little things, right? I don't know if you've interacted with a span panel before. It has a cap bank in it, and when you open the door, even if there's no power from the utility, the LEDs light up. So you can see what the breakers and the labels and kind of what's happening if something is stripped because of that, right? So I think simple things that make it a rich experience for the consumer, and for the installer, the same thing. Make the installation process super intuitive. Make the commissioning process super intuitive, right? Our our product requirement for meeting the bar for installers is an electrical contractor that opens the box and immediately flings the installation manual aside has to still be able to install it without any, right? And that just sets a really high bar for how you think about the physical design and the industrial design of the product.
Yeah, I love that. And I know those are easy things to kind of give in on as you go. Sure, it's one thing to have that vision early on when you think of a product, but then to actually like hold true to that through the whole process of, as other requirements come into play and your cost targets come into play, and you start to sort of erode that vision into something that's more realistically manufacturable and stuff. It's not an easy thing to kind of hold true to that like founding principle of this needs to be a beautiful, intuitive product.
Yes, there are a lot of misconceptions out there about how you bring costs down on some of these products. Obviously, part of it is good design. Part of it is design for manufacturability that I know you guys help a lot of companies think about, right? Part of it is scale. And I think, quite frankly, part of it is making sure that you're not cornering yourself with designs and unobtainium materials, right? At the end of the day, our product is, sheet metal, plastics, copper busing, cabling, and obviously electronics. And we own the design ourselves from the ground up, from every popcorn component on the PCB all the way to the final assembly. By doing that, we have a really good handle on the cost. We have a really good handle on the impact of changes to design or even changes to components from a second or third source on the landed cost of the product, right? And that helps us be very refined in how we think about our cost model and our cost down walk, if you will.
Yeah. Was that actually, that's an interesting point. Was that a really intentional kind of part of your development strategy to own the design ground up, as opposed to, I think what you're implying is that, you designed it all in-house, you own the IP, as opposed to going to a manufacturer of panels and white labeling something, putting a Span logo on an existing panel?
Look, on the one hand, strategically, we didn't want to be path dependent on somebody else's panel board or bus bars or breakers for a number of reasons, right? Like things change circumstantially and then we become less important, right? On the other hand is we humbly, I think we created a wholly new product category that didn't exist. There wasn't a thing called a smart panel when we started Span.
Right. You couldn't go get one and put a
Yeah.
Span logo on it.
That's
Yeah.
right. So I think by design, I wanted to create a product category that obviously is a little hedonistic to think we can create a new product category and be successful at it. But nonetheless, we have, because I think we had a unshakable conviction around the need for the product and a really, really strong focus on the design and engineering of it, right? From the mechanical design, the electrical design, the electronic design, test, reliability, certification was and is still in-house, right? And the selection of the MCUs that we use, the firmware that we write onto it, all of that is in-house, right? And that just gives us the agency to control outcomes as opposed to being at the receiving end of whatever changes. And I don't think we would have been able to survive through the supply chain issues that came during the pandemic had it not been for us having a strong understanding of the components of the system. I don't think we would have been able to navigate through the complexity of the tariffs over the past 12 months had it not been for the fact that we understood down to popcorn components what's in our product, right?
Yeah. Is knowing what you know now, is there anything you would have done differently about developing the product?
Oh, so much. I don't think we have enough time to go to that. Look, I think I say that in jest, but I think the overall roadmap has held. The timeline has slipped. Building hardware is harder than one wants for it to be. But that's okay.
I mean, you got your first product out, what, 2.5 years after you founded the company or something?
Less than that. That's a good point. Like, I think when I raised the seed round, I think it was a grand $3.5 million that we raised to build a whole new product category. The goal was within a year, we had to launch the first product, as in we had to announce the product, and it had to be not just looks like, but works like the thing that we wanted to ship. And that allowed us to collect purchase commitments and then ship a product in 2 years and go through certification in the second year, right? So I think it was a tall order task, but I think we had the right team to do it. We had an exceptional team. It was like we had one mechanical engineer, one electrical engineer, one firmware engineer, one cloud engineer, one mobile engineer, right? But we still got it done. But it was also like right sizing the effort, right? So for example, Gen 1, we said, okay, there are all these different types of homes. Some of them need main panels, some of them need meter combos, some of them need sub panels, some of them need 10 circuits, some of them need 40 circuits. Well, we can't build all of them. Let's build one product and let's make that a darn good product, right? So we built a 32 circuit version of the product because we 80/20 the approach to the market. And we learned a ton from that in the second generation product. And so now the last 18 to 24 months, we invested in a third generation platform and product that's a very modular architecture with a single 8 circuit, what we call a branch module. We can now stamp out 10,000 48 circuit panels. We can stamp out 10,000 16 circuit panels, all without having to redesign the core electronics, communications, firmware architecture. It's just, I need a slightly different size box and a slightly different size bus bar, and that's it, right? But we had to do Gen 1 and Gen 2 and learn what we had to from that to then make the investment in redesigning the system architecture for Gen 3, which was a substantive effort.
Yeah. Was part of that learning about what the market needs and what kind of flexibility you need in your design, or was that more?
It was all of it. It was, what does the market need? What SKUs to build that'll drive penetration of the home builder segment versus the retrofit segment versus the solar storage segment versus the utility segment. It's understanding what would be the right price point for the product that the market has positive receptivity to. What is the manufacturability of it? Like even simple design choices like, do we build a branch module with 6 circuits or 10 circuits? Or why is it 8 circuits, right? Like we went through excruciating analysis to arrive at 8 circuits is the right size circuit, right? And I think it was all the learning that came from the first 2 generations of products that we built and shipped quickly, right? Without necessarily all the bells and whistles we wanted to put into it, then learn from that and then feed that back in. The first generation product, we didn't have knockouts. And we had, electrical panels all have these little knockouts that you can sort of tap out with a screwdriver, right? And electricians were like, WTF, every electrical panel has a knockout. Why don't you have it? Like, yeah, you're right. But the manufacturing process was very complex at the time for us to introduce a knockout. So Gen 2 has knockouts. Gen 3 has an abundance of knockouts and easy ways for you to wire systems, right? So again, I think there was a ton of learning across the board, both in terms of what the market needs were, but also what was right from an engineering perspective, what was right from an operations or manufacturing perspective, what was right from a serviceability perspective, right? In Gen 1 and Gen 2, if there was an RMA, fortunately, we've designed it well that our RMA is very, very, very low for a outdoor product that's deployed in different climates. You had to replace the entire panel board. So this, 30-inch assembly came out, and it was still field replaceable, but now it's a 4-inch assembly that can be popped out and end very easily. Right? So I think all of that learning sort of feeds into iterative design, while at the same time ensuring that the new design that you come up with is less complex from a manufacturing perspective, less complex from a serviceability perspective, et cetera. Right?
Yeah, I think it's a great example of kind of the many stakeholders you have to think about when you're designing a product. And you have the homeowner, you have the utilities we talked about, you also have the technicians who are installing and maintaining these things.
That's right. And in the same vein, right, you have to think about who are your internal stakeholders as well, right? I think one underappreciated part of building hardware products, you can't just cobble together a bunch of components from somebody else. That doesn't make for a great product. You also can't afford to build everything in-house, right? You're not going to go down to the elemental aspects of building your own ASIC, for example. That's cost prohibitive, right? So knowing what is core to our IP and what do we need to own from a design and build perspective. I'll extrapolate on that a bit, right? We have a really capable supply chain and manufacturing operations teams that usually is embedded with our contract manufacturer, right? For the size and stage of company we have an incredible OT platform where we have genealogy and traceability in every component that goes into every panel, right? Like we have the ability to say, you give me the serial number of the product, I'll tell you all the way down to who was the person on the line that assembled it, to what op-amp components that went into it, to what pieces were changed between Rev 1 to Rev 17 or whatever it is, right? And I think that's usually an afterthought for a lot of hardware companies and product companies. And I think, again, testament to the team, we have a lot of people that have the right experience to say, we should instrument this now so that we understand it. We should design it with intent now.
Maybe kind of building on that idea of different stakeholders and different perspectives on the product. How have things changed in the 7 years since you started this from a kind of regulatory landscape? And I'm particularly thinking about our current administration and their perspective on rebates and incentives and things for home electrification, and how much is that changing your strategy with your product and your outlook for the company?
Yeah, look, I think the semantics around climate change, climate tech, Inflation Reduction Act, or electrification, all of that aside, our focus has consistently been building a solution that has an economic value today, irrespective of what subsidies and rebates are out there, right? That it should not be path dependent on policy or regulation changes whatsoever, right? And I think we've accomplished that. So much of what we talk about today is not how tariffs and rebates and subsidies impact us. There are some macro impacts in terms of, obviously, interest rate also has an impact on the rate at which homes are built and consumer purchasing behavior. Obviously, the change in NEM 2 to NEM 3 had a change on the rate at which people are adopting solar and therefore batteries and therefore Span. Obviously, the changes in EV adoption because of the sunsetting of the EV tax credits is going to have an impact on macro purchasing behavior, adoption patterns. But our product fundamentally is not path dependent on any single one of those to be or value add to a customer, right? So we like to think of the solutions we're building as being infrastructure solutions that are necessary if you believe that load growth is happening, right? EVs, heat pumps, induction cooktops, manufacturing, compute, then our product has a place in the world and it'll scale, right? And that's kind of how we've tried to think about the product pricing and the market opportunity for us overall.
Yeah. Load growth is happening, and also we have a greater mix of intermittent supply on the grid too, right? And that must play a big role for you.
That's right. So I think the combination of, so I'll give you sort of the glass half full view of this, right? Load growth is happening not because people are buying these electric appliances purely out of a sense of consciousness, right? they're buying it because they're good products. People are buying electric cars because they're comparable, if not better, to gas cars that they've driven before. You're buying an induction cooktop because it's good to cook on. You're buying a heat pump because it's a good heating and cooling system for your home, right? So that load growth is happening irrespective of what incentives are being provided to advance those product categories, right? We actually see more of the utility growth coming from utilities having to keep up with this load growth while now also having to make decisions through the lens of affordability, right? Regulators and ratepayers are telling utilities now, hey, you can't keep jamming us with larger and larger electric price hikes for spending millions of dollars of capex on infrastructure that arguably we don't need, right? Especially there are lower cost solutions like Span that can meet the same objective, right? So I think in a way that regulatory, let's call it constraint of saying, hey, utilities, you got to come to me with a solution that is less expensive and more affordable, right? Is making it better for us to survive or thrive, right?
Right. You are that solution.
That's right. And same thing
Part of
with
it, yeah.
tax credits for solar and batteries. If I need I need fewer batteries or a smaller battery, because Span can do load management and allow me to extend my outage coverage, right? We have empirical data that says that a Span panel unlocks 1.4x the amount of outage protection for every unit of battery that you have, right? And that's because we are seeing in real time your must have, nice to have, and non-essential loads, and we can turn them off based on a schedule or based on preferences, the case may be, right? So now I've reduced the cost burden on the customer for a similar size system with a panel product. So regardless of what the tax credit benefits are, Span should make sense to you if you're looking for a backup solution, right? So I think those are the things that we spend more time focused on because it's really, really hard to be reactive to the changing policy, especially now.
So in a lot of ways, you're 5 years ahead of many of the guests I've had on the show and many of our listeners, in the sense that many people I talk to on the show are kind of at the early stage of developing a product, or maybe they have their first pilot product out on the market, or you've been doing that for 5 years. Maybe this is a tough question, but I'm curious, like, from your perspective now, having been through that, and on your third generation of your product and everything we just talked about, what advice do you have for somebody early in that process right now?
Yeah, and look, with all humility, right? This is not my first time trying to build a company, and I did not get it right in the first go either, right? These, especially for hardware products, I think it's there's a learning curve, or there's a borrowed learning curve or an informed learning curve, however you look at it. I had Tesla was a great learning environment in terms of scaling physical products from naught to hundreds of thousands of endpoints. And I learned a ton there. And then before that, I built a metering disaggregation company where we worked with contract manufacturers, and I learned how not to rely on CMs too much for helping you design solve. And I worked at Joby Energy way back when we were designing, very prototypical systems of aircrafts on tethers that could harness wind power, right? And while we never got to scale of productizing it, there's a complexity of design there, from carbon fiber wings to rotors to stators to battery systems, etc. Right? So all that to say, I didn't just wake up and start building good products at Span. It's taken some time to do that. The advice that I have perhaps is a little bit more centered around just having deep conviction around the product that you're trying to build. You should understand the domain really well, and especially if you're a technical founder, gosh, you got to know your system architecture better than anybody else does, right? I think there are a lot of often missed opportunities in system design, not because people design things poorly, but because, in fact, people design things really well. What I mean by that is, if you take a highly capable electrical engineer, a highly capable mechanical design engineer, a highly capable cert engineer, put them in a room and say, build a product, they each like you to build the best version of the product that they think they can build, right? And sometimes that's an overshoot in terms of the solution you've engineered. So if you're able to look at it at a system level, we actually have a systems architecture team, a couple of PhDs, one in the high voltage domain, one in the low voltage domain, that are constantly looking at product decisions and design decisions we're making to ensure that not only does it meet the design intent, that we haven't unnecessarily over-engineered something that's going to come and actually haunt us later. So long way of saying, be deeply involved in the design and system architecture early on, and make sure that you understand what trade-offs and choices you're making.
Yeah, you're the only person who has that kind of full system view and the business kind of constraints and requirements, everything. Yeah, I love that. Yeah. What's next for Span? What's on the roadmap? What's the future look like?
Impact at scale. I think the focus for us is how do we deploy these products at massive scale. We talked a little bit about how utilities are going to be a change agent for us and an accelerant for us as a partner, and I'm really encouraged by the receptivity we're getting from utilities around the solutions we built. I think that's part of it. I think the panel is the most important flagship product for us, but we obviously have an EV charger that is, I still believe, is the best sort of dynamic EV charger in the market, but expanding beyond our own products to interoperability other products and other adjacent devices that we should pair with, right? Be it storage, be it heat pumps, be it vehicle to home solutions. Those are products that you'll hear us talk about and bring to market or bring to life here in short order.
Cool.
Yeah.
I have 3 questions that I ask everyone at the end of each episode. The first is, how optimistic or pessimistic are you about the future of the planet and why?
I am quite optimistic, but I'm also generally, somewhat irrationally optimistic about things. If you set aside the noise of the geopolitical environment, I think there are a lot of people that actually genuinely care about building things that matter. And especially where we are here in the Bay Area, right? I think if we keep focusing on building solutions that makes not just our lifestyles better, but also how we consume things better, I'm quite optimistic about the trajectory that we're on, at least for the next, let's call it, half a century. Yeah.
It's a pretty good chunk of time.
Yeah.
Who is another company or individual doing something to address climate change that's inspiring you?
That's a good question. Two folks that are good friends and mentors of mine that come to mind, JB Straubel, who's doing Redwood Energy, Redwood Materials, where they're building one of the largest US-based recycling facilities and increasingly looking at ways to use the batteries. I think it's really cool, really impactful. He's always been an inspiration to me, and even since when I came into Tesla, thanks to him. And then Joe Ben, who is building Joby Aviation, that's pretty cool and impactful business as well. Jury's out on how fast we can all be helicoptered around an electric aircraft, but I think it's the kind of moonshot solutions we should be working on, right?
Yeah, love it.
Those are, close in my peripheral vision, right? And I see the progress they're making, and it's just incredible to watch. Yeah.
What advice do you have for someone not working in climate today who wants to do something to help?
Be committed. Don't be a climate tourist. That is unhelpful in many ways. So climate is not about, it's not about being cool or sexy. It's about actually longitudinal solutions. These things take time to build and time to see the impact of. So if you are truly interested in solving climate problems, many of them are hard problems. Many of them take a certain amount of integration over time, type of patience to see the value of the effort that you put into it. So come on board. You should help. It's a good starting point, but know that you need to stay in order to deliver value.
Yeah. Well, thanks for setting a good example there. Really enjoyed our conversation. I appreciate it. Thank you, Arch.
Likewise, great to chat with you.
Hardware to Save a Planet is brought to you by Synapse. To find out more about us and how we develop hardware solutions for the world's most ambitious companies, head to synapse.com. And then make sure to search for Hardware to Save a Planet in Apple Podcasts, Spotify, or anywhere you like to listen. Make sure to click subscribe so you don't miss any future episodes. On behalf of the team here at Synapse, thanks for listening.